Hey, this is Charlie Thompson, and welcome to Lab 2, Earth-Sun Relationships and Day Length. I've made a whole bunch of videos for this lab that cover the basics of how the seasons work, of how day length works, and so this video is just to cover some of the issues that students have had in past semesters that weren't really covered well enough in the other videos. So it's a quick video that's just concentrating on some of the things that people have had issues with or problems with in the past. So the beginning of the lab tells you what you should know. So that's a good place to start. After this lab, you should be able to label diagrams representing Earth-Sun relations in the annual March of the Seasons. So the March of the Seasons is just the sun, or rather Earth, going around the sun, and we see spring, summer, fall, winter. That's the March of the Seasons, and at different times of the year, the sun is over different latitudes. There's videos and animations that go on and on. I didn't want to include them here because then every video would be like 4 hours long and nobody would watch anything. So you're supposed to be able to look at a diagram showing where the sun is and figure out what season it is. You should know the dates and the subsolar points of the seasons, and I'll go over that in a minute. The second thing we're going to be doing in this lab is we're going to be calculating day length during the year. So day length at different seasons, and then day length at different latitudes on the same day. Because on the same day, some places have 12 hours of light, like the equator, every day. And at high latitudes, they go from 24 hours of darkness to 24 hours of daylight. So latitude plays a huge role in seasonality. In fact, it's such a big role, we will continue to explore next week. So latitude is super important. 95% of everything in physical geography is because of latitude. So when we're looking at patterns of temperature or rainfall, 95% of it is going to be because of its latitude. And the other 5% is because of plate tectonics, and that does things like makes mountains or continents. So yeah, 95% of everything is latitude, and the other 5% is plate tectonics. So here we've got Google Earth, and you can see over the equator, you can see just looking at Africa. Africa is a great example of the effects of latitude. So we have tropical rainforest where it's rainy every day of the year. And then we have some savanna where it's rainy half to 3/4 of the year. And then we get into desert. And then moving up, we end up in a Mediterranean climate as we continue to go north. Portugal, Spain, France, Italy. The whole Mediterranean has a Mediterranean climate with dry summers and wet winters. As you continue to go north, it goes from, in the desert, dry all the time to dry in the summer to rainy year-round. And then as you get farther and farther north, it's just very cold. We're going to study how latitude affects day length over the year, how at one latitude we have different day lengths at different seasons. For example, at the equator, there's no change. Every day is 12 hours. The poles go from 24 hours of daylight in the summer to 24 hours of darkness in the winter, and everybody in between has an in-between amount of change between summer and winter. And why are we talking about this? Well, because the sun provides all the energy that powers weather and climate on our planet, and also life, plants that are eaten by animals. So unless you are bacteria, chemosynthetic bacteria existing by a hydrothermal vent in the deep, deep dark where they never see light parts of the ocean, you're getting your energy from the sun. If you're eating plants, the plants got their energy from the sun. If you're eating animals, the animals ate the plants and the plants got their energy from the sun. And latitude is going to show us, well, through this lab, hopefully you'll figure out the effects of latitude on the length of sun, like at the poles, 24 hours of daylight, at the equator, 12 hours of daylight. And that's why we talk about it, because it creates these different patterns all over the Earth, different amounts of energy from the sun, different amounts of daylight, different changes in daylight between summer and winter. That's why we're studying this. So we're going to study later on, one of the things that's important, where the sun is directly over during the year. The name of that location is the Subsolar Point. So if you imagine the sun shining on the Earth, it's hitting some point at a 90-degree angle. We call that the subsolar point. As Earth turns, that point, like if you marked the globe with a pencil and turned the globe, that pencil would make a line, that line of latitude. is the subsolar point, and it moves from the Tropic of Cancer, 23.5 north, to the equator, to the Tropic of Capricorn, 23.5 south, back up to the equator. It just goes up and down over the year. You should also start remembering the names and dates of the seasons, where the subsolar point is on those seasons. I would make a chart. There's great value in actually making the chart. Writing it down activates parts of the brain that make it easier to remember. So you could take a picture, but you won't remember it nearly as well as if you just write it out by hand. So I would write out like the name of the seasonal event. For example, the March equinox. Where's the subsolar point? It's at the equator. And what's day length at these different latitudes? Well, on the equinoxes, the sun is at the equator and everyone has an equal amount of day and night. On the equinox, the sun is at the equator, everyone has an equal amount of day and night. So the March equinox, that's coming up. The subsolar point will be at the equator. Everybody will have 12 hours of daylight. 3 months from that, the June solstice, what we think of as the summer solstice, the subsolar point will have moved 23.5 degrees north of the equator. It'll be over the Tropic of Cancer. Everybody north of the Arctic Circle, if you're at the North Pole, you'd have a 24-hour day for months. Everybody at the equator still has a 12-hour day. Everybody at the South Pole gets no light. 3 months later, the sun's at the equator. It's the equinox, equator, equal day and night. And then 3 months later, the December solstice, the subsolar point has shifted to 23.5 degrees south. So the North Pole gets nothing. The equator gets 12 hours and the South Pole gets, again, 24 hours of light. So if you're at the poles, you're going from 0 hours of daylight to 24 hours of light over the course of a year. And if you're at the equator, you get 12 hours of light every day, no matter what. So calculating changes in day length or amounts of daylight, there's 3 ways we can do this. There's 3 ways you can do it. I'm going to show you what they are. Pick the one that works for you. We've got math by hand, using an online calculator that calculates duration, or you can use Google Sheets. And that's what I started doing because that way I don't need to worry about making a mistake punching in the number, because I can look at the number in the sheet and go, oh yeah, all my inputs are right, my formulas are right, the output has to be right. Don't just plug the numbers into your calculator, because time is base 60. You know, there's 60 seconds that make a minute, 60 minutes make an hour. And math, our math is base 10. So if you plug like 742, thinking that's 7 minutes or 7 hours and 42 minutes, now your calculator, that's 42 100ths is what that is, not minutes, and it'll give you a bad answer. So I don't just plug the numbers into your calculator. Let's do some math by hand. Example, sunrise, 6:45 a.m. Sunset is 6:27 p.m. I just picked these numbers at random. I didn't pull them from anything. It's easier if you can convert p.m. to 24-hour time, and you do that by just adding 12 hours. Everything afternoon, you just add 12 hours to the hours. So 1 p.m. plus 12 hours is 1,300 hours. 6 plus 12 is 18, so 6:27 p.m. is 18:27 in 24-hour time. Like I said, I find it easier because there's no question, was that a.m. or p.m.? So sunrise is 6:45, sunset is 18:27. So we can start with the minutes. 7 minus 5 is 2. That's good. But then now we've got 2 minus 4. So we have to borrow an hour. So the 18 hours becomes 17 hours. And then we're going to add 60 minutes to the 20 minutes, because that 2 really means 20 minutes, right? So 20 minutes plus 60 minutes is 80 minutes. And then 80 or 8, right? Because this is the tens column. So 8, that's really 80. 8 minus 4 is 4. So 80 minutes minus 40 minutes is 4 minutes. We already have the 2. And then 17 minus 6 gets us 11. So if the sunrise is 6:45 a.m. and the sunset is 6:27 or 18:27 hours, then the day length is 11 hours and 42 minutes. I think the thing that, it's the borrowing that seems to mess up people, and calculators can't borrow if they need to. They'll borrow using base 10 and your answer is going to be wrong. So we've got math by hand. You can go to time and date. I've put the link in the resources for this lab. Yeah, the webpage tells you how to do it. You can just leave the months and days blank, enter the hours, minutes, and you can leave the seconds blank too. Just enter the starting hour and minute, the ending hour and minute, and it'll tell you what that duration was in hours, minutes, seconds. And you can use Google Sheets. You can format numbers as times, like 5:26 p.m., or that would be 17:26 p.m. And you can format one column as duration, which is an amount of time. So here we go, and let's take a look at this. Okay, so here we've got a Google Sheet, and I've set it up so that I formatted this column. I went to Format, Number, Time, and this column I went to Format, Number, Duration. So these are times and these are durations. And then I set it up, subtract B4 from B3. So subtract time 2 from time 1. I've put a link to this. It'll make a copy and save it to your Google Drive account, and you can just plug in different numbers. Okay, so this is the Google Sheet, and we've got space for time 1, the starting time, time 2, the ending time, and then the duration. So let's look up on time and date. That's the way you're going to be doing this. All right, so I just went to time and date for Davis because that's where I live. I thought I would use the information today. So if you scroll down to the 23rd, there's today, and it says sunrise 7:19, sunset 5:18 p.m., day length 9 hours 59 minutes. So the day length is often calculated for you. And in these examples, I've just told you just ignore the seconds. So like I would round that to 10 minutes, but the right answer would be 9:59, I think, because 7:19 to 5. Well, let's figure it out. What I'm going with this is when you look at the day length, yeah, I would use that. Am I in the ballpark or am I like completely wrong? So let's take these numbers, 7:19 a.m., 5:18 p.m., and see what we come up with. So we've got 7:19 a.m. and 5:18 p.m. So it converts them over into this hours, minutes, seconds format. Notice it's in 12-hour time. So instead of 17:18, it's showing up as 5:18. And then this, the duration again, is just time 2 minus time 1. So the answer for this, 9 hours and 59 minutes. So yeah, you can just delete the numbers here and plug new numbers in to your heart's content, and it'll give you the duration in hours and minutes. We're just going to ignore the seconds. That's it for week 2, lab 2. I wish you good luck on this lab. If you have any questions at all, please come to Zoom or send me an email, give me a phone call, write me an email, whatever you're comfortable with. As a reminder, if you come to Zoom, you don't have to turn your camera on. I don't care. I just want you to get the answers to your questions. So I encourage you. If you have any questions at all, please come to Zoom. I would be willing to bet, based on past semesters, 5 minutes conversation is usually enough to clear up any confusion and get you on your way. So, good luck.